Question: A friend tosses a baseball out of his second-floor window with an initial velocity of 4.3 meters per second. The direction is 42 degrees below the horizontal. The ball starts from a height of 3.9 meters, and you catch the ball 1.4 meters above the ground. A. Calculate the time the ball is in the air. And B. Determine your horizontal distance from the window. C. Calculate the speed of the ball as you catch it. So we set the starting point of the ball as the 0 point. So the ball starts from here, the 0 point. And this direction is positive y direction. This direction is positive x direction. And here is the ground. So from the starting point to the ground, this distance is 3.9 meters. And this is the velocity, initial velocity of the ball. Initial velocity. And this angle is negative 42 degrees. I set it as negative because it's below the horizontal direction. And the ball moved along a parabola curve, and you catch the ball at here. So from this place to the ground, the distance is 1.4 meters. You catch the ball at here, above 1.4 meters above the ground. And we know the initial velocity is 4.3 meters per second. And the angle theta between the direction of the initial velocity and the horizontal line is negative 42 degrees. I set this as negative because it's below the horizontal line. Then its vertical displacement equals it's negative than 3.9 minus 1.4 equals negative 2.5 meters. It's negative because the direction of its vertical displacement is down. It's opposite to the positive y direction. So from the starting point to the ending point, the vertical distance is 2.5 meters. Then question A, it asks for the time the ball is in the air. So it asks for the time interval. So we start from this formula. We know the final velocity square, final vertical velocity square equals the initial velocity multiplied sin theta square minus 2 multiply acceleration g multiply vertical displacement. So the magnitude of the final vertical velocity just equals square root inside the initial velocity multiply sin theta square minus 2 multiply acceleration g multiply the vertical displacement. Then this equals, we put the values inside. This equals the initial velocity is 4.3 multiply sin negative 42 degrees. Then square minus 2 multiply the acceleration 9.8. Then multiply the vertical displacement negative 2.5 meters. Then this equals 7.57 meters per second. So the final vertical velocity equals negative 7.57 meters per second. It's negative because its direction is down. Then we know this formula. The final velocity equals the initial velocity multiplied sine theta minus acceleration g multiplied time interval delta t. So from this formula, we can get the delta t time interval just equals the initial velocity multiplied sine theta minus the final velocity, the final vertical velocity over acceleration g. And this equals the initial velocity 4.3 multiplied sine theta. Theta is negative 42 degree. Then minus the final vertical velocity is negative 7.57 meters per second. The acceleration 9.8. This equals 0.48 seconds. So the time interval is 0.48 seconds. Now for question B, it asks for your horizontal distance from the window. So it asks for the horizontal displacement of the ball. So it's this formula. The horizontal displacement equals the initial velocity multiplied cosine theta multiplied time interval delta t. Now this equals initial velocity 4.3 cosine negative 42 degree. Then multiply time interval 0.48 seconds. So this equals 1.53 meters. So its horizontal displacement is 1.53 meters. It is also your horizontal distance from the window. Now for question C, it asks for the final speed. So we know its final horizontal velocity equals the initial horizontal velocity equals the initial velocity multiplied cosine theta. And this equals 4.3 initial velocity multiplied cosine negative 42 degree. And this equals 3.2 meters per second. And we already know its final vertical velocity equals negative 7.57 meters per second. It's here. Now I draw them. This is the final horizontal velocity. Final horizontal velocity. And this is its final vertical velocity. And this is just its final velocity. This is a rectangle. So from this graph, we can know that the magnitude of its final velocity equals square root the magnitude of its final horizontal velocity square plus the magnitude of its final vertical velocity square. And this equals square root. It's 3.2 square plus 7.57 square. And this equals 8.22 meters per second. So its final speed is just 8.22 meters per second.